Hey math fans! Welcome to Math Olympiad Academy, your trusted space for advanced problem solving and logical reasoning. We sincerely thank our subscribers and all viewers for your continued support. In Lesson 21, we present a rigorous, step-by-step solution to an integral with repeated roots, an integral that looks tricky to many students, but isn't when you know the appropriate method. Let us consider the following expression. J equals the integral of dx over the quantity x cubed minus 2 times x squared plus x. Can you determine the integral j? Our objective is to find the integral of 1 over the quantity x cubed minus 2x squared plus x, and in doing so, grasp the method of partial fraction decomposition, especially for rational functions with repeated linear factors. Before we begin solving, let's take a basic first step. Understand what we're integrating. After that, a natural question arises. Where should we begin? Now, recall the integrand. 1 over the quantity x cubed minus 2x squared plus x. To proceed, begin by factoring the denominator completely. Specifically, factoring out x, we get x times the quantity x minus 1 all squared. So the denominator becomes x times x minus 1 squared. In step 2, we decompose the rational function into partial fractions. The fraction 1 over the quantity x times x minus 1 squared is expressed as a over x plus b over x minus 1 plus c over x minus 1 squared, where a, b, and c are real constants to be determined. Now, the question is, how do we find these constants? In step 3, we determine the real constants a, b, and c applying an efficient method. First, multiply both sides by x times x minus 1 squared. This gives 1 equals a times x minus 1 squared plus b times x minus 1 plus c times x. Set x equal to 0. We get 1 equals a times 1, so a equals 1. Set x equal to 1. We get 1 equals c times 1, so c equals 1. To find the constant b, let us set x equals 2 inches the previous identity. This gives 1 equals 1 plus 2 times b plus 2. Simplifying, we get 1 equals 3 plus 2 times b. Subtracting 3 from both sides gives minus 2 equals 2 times b. Dividing by 2 yields b equals minus 1. So a equals 1, b equals minus 1, and c equals 1. This yields 1 over x times x minus 1 squared equals 1 over x minus 1 over x minus 1 plus 1 over x minus 1 squared. Now, to determine the integral j, let us integrate the partial fractions. Since the integral of a sum is the sum of the integrals, we write j equals the integral of dx over x minus the integral of dx over x minus 1 plus the integral of dx over x minus 1 squared. For more clarity, we integrate each partial fraction separately. The first term, denoted j1, equals the integral of dx over x. Since the natural logarithmic function is the general antiderivative, or indefinite integral, of 1 over x, this integral j1 is the natural logarithm of the absolute value of x, plus an arbitrary real constant denoted c1. Now, let us move to the second term, denoted j2, equals minus the integral of dx over x minus 1. This is equal to minus the natural logarithm of the absolute value of x minus 1, plus a real constant denoted c2. Finally, the third term, J3, is the integral of dx over x minus 1 squared. This can be written as the integral of x minus 1 to the power minus 2. Its integral is minus 1 over x minus 1 plus an arbitrary real constant denoted c3. Thus, the sum of the integrals j1 plus j2 plus j3 equals the natural logarithm of the absolute value of x minus the natural logarithm of the absolute value of x minus 1 over x minus 1 plus an arbitrary real constant denoted c. Conclusion: the integral j equals the natural logarithm of the absolute value of x minus the natural logarithm of the absolute value of x minus 1 over x minus 1 plus an arbitrary real constant denoted c. And by applying the properties of the natural logarithm, this can also be expressed in the simplified form. J equals the natural logarithm of the absolute value of x over x minus 1 over x minus 1 plus an arbitrary real constant denoted c. I hope you enjoyed this step-by-step solution. Keep practicing, share this lesson with your friends, and don't forget to subscribe to Math Olympiad Academy for more exciting math challenges. See you in the next lesson!